So the next thing we need to start with is the events. So we have seen this, discussed this yesterday. Events are nothing but the an event. An event is a subset of the sample space. A subset of a sample space is it consists of some or all the points of sample space. It consists of some or all points of sample space. I also said that we'll also see what is Venn diagram. Venn diagram generally consists of are like this. So you have a square which will represent the complete sample space. So this will be sigma and an event inside it. An event is the Venn diagram. Later, these Venn diagrams will play a major role for just understanding purpose. So you may have some outcomes which are in the intersection of the two events. Some are going to be mutually exclusive, exhaustive, and all types of events we'll see. Okay. So before going to that, we'll also see the definition. What do we mean by occurrence of an event? I won't write the definition, but the word itself says the meaning of occurrence of an event. Yes, anyone? Occurrence of event. If after performing the event, if after performing, performing the experiment, performing the experiment, outcome belongs to the event. Outcome, outcome belongs to the event. So I'll perform certain experiment and then, so for an example, I'll write down one example. What this example, coin is tossed thrice. This is my random experiment. Uh, the coin is unbiased coin. What do we mean by unbiased?
A fair coin.
No, fair coin. So
Equal
which are
possibility of heads or tails.
equal possibility of heads or tail. So such a coin is tossed. What will be the sample space? Head, head, head. Either you will get all three times head, or you'll get
Sir,
one
it will
time
be 8.
head, tail. tail, head, head, then tail, tail, head, tail, head, tail, head, tail, tail. All the three are tail. Okay, so three are there. Three times a coin is tossed. In all there are 8 possibilities that we can get. So I'm defining the event now. Event A. What is my event? Occurrence of a single head. Occurrence of single head. So the event A will consist of how many elements?
Three.
3.
Yeah, that's it. Yes, three are going to be occurrence of a single head. So single head, tail, tail, head, tail, head, tail, head, tail, tail. So we can define another event there where minimum two heads will occur. At least two heads occur. Then
4.
four will be there. So this is the way. I mean, you can see that it is whatever we are calculating, that is simply the subset of this. So I'll define the another event B as occurrence of at least one head. So B is going to be
7.
7. So those are going to be at least one, which means this will be there. 1, 2, 3. Yeah. So head, 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 tail, head, head, tail. These two events I have took because after this, what we are going to discuss is we are going to discuss the case where different types of events are going to be there, and to understand those events will require these examples. Okay, so if I try to draw the Venn diagram for this, okay, let's not draw the Venn diagram, it will confuse right now. Anyways, I'll just end it over here and we'll go for the types of events. So the next is the types of events. What different types of events do we have? Let's not waste time writing each and every definition, because many of the names are self-explanatory. Just looking at the event, we'll be able to write down we'll be able to understand the meaning of it. Elementary event, elementary event, or simple event. So these are the events where only the event containing only one element. The event containing only one element. Such a events are called the elementary event or the simple event. Second, impossible event. Yes, I said that it is self-explanatory. Many of them are going to be self-explanatory.
Probability of occurrence of event is 0.
Okay. We haven't even defined the probability yet. Can you
Yeah.
simplify
No
it?
possible outcomes.
No possible outcomes. An event corresponding to empty set. I mean, the same thing that you said. Even the probability of occurring is 0 if the set is empty. The event corresponding to corresponding to empty set is not possible. I mean, whenever you perform an experiment, there is going to be some outcome, and that's why the event is impossible event. Third, sure event or certain event. Which event is certain always? Even without performing the experiment, you can say that this is going to be the outcome.
Addition of two
The
numbers
event,
shall always have a sure value.
No, no, we are talking in terms of
event which
non-deterministic.
belongs to deterministic experiment.
So
No,
sample space.
yes, exactly. The very good. So it is the sample space. You can always say that the outcome is always going to be uh, in the sample space, right? You first of all, someone said that talked about deterministic experiment. Let me just make it clear that we are concerned here with non-deterministic experiments. Okay, because there is nothing to study in deterministic experiments. We already know the outcomes. Okay, so whenever we are going to talk after this, we'll be talking about uh, the non-deterministic experiment. Fine. So the answer is correct. Whenever you perform an experiment, the outcome will be always in the sample space. So an event containing all the points of sigma or S is called sure event. It's called sure event. Next, mutually exclusive events. This you know. I won't write the other name of this. I'll leave a space. Yes.
If the occurrence of one event exclude the occurrence of another event.
Can you repeat that?
if the occurrence of one event excludes the occurrence of another event.
Okay. Anything else?
When
We
two
don't
events
have
do
the
not occur at the same time.
Both events?
Do not occur at the same time.
But this is quite.
they don't have a common point.
Yeah, they don't have any common point, which means that those two events are
Really exclusive event.
disjoint. Can I say that? The sets are disjoint. So that's why this is also called disjoint events. The events A and B are said to be mutually exclusive, are said to be mutually exclusive if there is no common element. If there is no common element in A and B. So, which means that if I talk in set theoretic form, then A intersection B is equal to phi. Uh, you have a set theory also in discrete mathematics. Anyone can you respond to this? You have done basic set theory in discrete mathematics or not? Yes, sir.
Yes, sir.
Yes,
Yes,
yes.
sir, we
Yes,
have.
sir.
Fine. So we don't have any problem. Fifth, complement of an event. If I draw the diagram for this one, how it is going to be? So both the sets will be disjoint. Okay, there is no common point between A and B as we can see here, and there is this sigma. Complement of an event.
Sir, it is a set of outcomes which are not included in the space.
Yeah. So complement complement of an event A is denoted by A dash and consists of all the points and consists of all points of sigma which are not in A. Fine. So if we have A here, then this remaining part, this one, this is nothing but A dash, the complement of the event A. Also, what we can see here, A union A dash is equal to what is A union A dash? Partner, is it so difficult? Sigma.
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 Yeah. The last one is exhaustive events. Again, something that you know.
If all the elements come together and consume the same sample space.
Can you repeat that?
The event together consume the same sample space. Like all the
Consume. Yeah. Uh, so if you make the union of those two events, we'll get the complete sample space. Okay. So events A and B are said to be exhaustive events. Are said to be exhaustive events if A union B is equal to sigma, complete sample space. The definition we have written for simply A and B, we can also generalize it to A1, A2 up to AN, and said to be exhaustive if A1 union A2 union so on up to AN, this becomes sigma. Just before we end this, remark one, AN A dash are A dash and A are A dash and A are which type of events?
Complement.
Those are complement, but what are the type? What can we call them?
Mutually exclusive.
Mutually exclusive.
Impossible event.
Impossible event.
Oh no, we can call them
Exhaustive. Exhaustive.
Yes, those are exhaustive events. Second, mutually exclusive and exhaustive events. Mutually exclusive and exhaustive. So what I want you to do is you take two events A and B. Both are mutually exclusive and exhaustive. What will happen? Can you draw the Venn diagram for this? Think of Venn diagram and what do you get there?
They'll cover the whole sample space.
It will cover the whole span sample space. What about the intersection of both of them?
There won't be an intersection, but drawing a rectangle and drawing a vertical line dividing the whole sample space into two parts.
Exactly. If I take A, B, and C, then
dividing the sample space into three equal, but
It will divide the sample space into three equal parts. So what can I say? Mutually exclusive and exhaustive events are nothing but what it is doing. If I take three
Exhaustive.
event, those are exhaustive. We are considering those exhaustive. So if I take two events, your sample space was divided into two parts. If we take three events, then the sample space was divided into three parts. If I take four, then it will be divided into four parts. So can I say that these are partition of the sample space? So we are going to encounter this type of events a lot of times. Mutually exclusive and exhaustive events. Okay, remember this. This plays a very important role. So if you take the union of all of them, it will become the complete space. If you take intersection of them, you will get phi. Fine, we'll just see some of the set theoretic properties, uh, and then we will go ahead for some examples.
So,
Yes,
in mutually exclusive and exhaustive events, A intersection B will be zero, right? Or phi.
yes.
Okay.
The first one, A complement complement. Second, sigma dash. Third, these are very simple. You will not require so much time. A union sigma equal to fourth A intersection sigma De Morgan's law. Fifth one, if A is the subset of B, then A union B equal to and A intersection B equal to. Yes. Is the first one A complement complement B
A.
A.
A sigma dash equal to
Phi.
phi, which is
Amplitude.
the event is called which event?
Exhaustive.
A, uh,
Impossible event.
impossible.
Possible in impossible.
A union sigma. Third one A union sigma is
Sigma.
Sigma.
fourth one A intersection sigma.
A complement.
A.
It is simply
A.
De Morgan's law. Now, by the time you think, I'll write this down. A phi A union sigma is sigma A intersection sigma is A. What is De Morgan's law?
Sir,
Hmm.
A union B dash का whole
A,
dash
A union B
whole
dash
whole dash is equals
equal
to A dash intersection of B dash
B dash and
and A intersection B का whole dash equals to A dash union B का dash.
okay. The last one. Last one is simple, I guess. This is the last one.
B and A.
A union B is B and A intersection B is A.
Sir,
Hmm.
is that if A intersect subset of B, then we need to find these values.
Yeah. Yes, the last one. What I want you to do is, yeah, I want you to write down A union B equal to the unions of mutually exclusive events. What I said, I hope the question is clear. I want you to write down A union B as the union of mutually exclusive events. Okay, so if you're not getting, I'll just, for your understanding, I'll draw the diagram also. This is A, this is B. I want you to write down A union B as the union of three, whatever. Uh, I want you to write down A union B as the union of mutually exclusive events. No one? No one.
I didn't understand what to do here.
I want you to write down A union B as the union of Mutually exclusive events. Are A and B mutually exclusive here? You can see the diagram.
No,
No.
sir.
No, sir.
So I want you
They
to
don't
write down.
have common points.
Yes, Sakshi.
They don't have outcome, like not common outcome.
No, there is an intersection that we can see. But I want you to write down A union B as union of mutually exclusive events. Okay. Anyways, I'll write it down. So A intersection B complement union. A intersection B union. A complement intersection B. Right?
Yes, sir.
So when you take A intersection B complement, you will get just this part, this one, right? When you take A complement intersection B, you will just get this much part. And then you have A intersection B, which is this. So all three don't have any intersection. So we have written A union B as the union of mutually exclusive events. Seventh, A is equal to A intersection B union A intersection B complement, and B is equal to A intersection B union A complement intersection B. Now you can draw the diagram and see what we have done here, what we are trying to do. Yes, anyone who observes it.
In both the sets, A intersection B is common.
Not that. Anyways, you think over it later. I'll write down an example. Let ABC are any three events on a sample space. Let A, B, C are any three events on a sample space. Sigma. Write expression. Write expression for the events. First one, at least one of ABC occurs. What will be the expression? Look, what do I mean? At least one of the ABC occurs is that you need to create a sample space, or you need to create an event which satisfies the given condition. I mean to say, whatever outcome will be there, it will be in A, or it will be in B, or it will be in C. You create an event which will consist of all the sample points which are in A, B, and C. What will it will be? Am I clear? Have you understood what you have to do here?
Yes, sir.
Yeah. So you need to create an event which will occur if the outcome is from A or B or C.
A union, B union, C.
Exactly. A union, B union, C. Only A occurs.
A union B intersection C.
Why?
Okay.
Be quick. This is not so difficult. So your outcome should be only in A. It cannot be in B or it cannot be in C.
A
So
union A dash.
no,
A union, B union, C complement.
uh, no. This is A. This is B. This is C. What you need is you need your outcome only in this part A. It cannot be in B or it cannot be in C.
A intersection, B union, C complement.
Which can be further simplified as A intersection B union C complement, which can be written as B complement intersection C complement by
C
De
complement.
Morgan. Third one, A and B occurs but not C. I'll just remove that line. Yeah, so this is A intersection B complement intersection C complement. What about the third one? You have to be quick, you have another lecture.
So I'm not sure about it, but A union B complement
Hmm.
intersection A complement union B complement
Let me
B
write it down. Let me write it down here. A
union
union
B complement.
B complement
So sorry, it will be intersection, not the union.
A intersection B complement
Union
union.
A complement.
Why you're doing A and A again? This is commutative. A union A complement will simply become sigma. Do you know? I hope you know what is commutativity. commutative. You said that A intersection B complement union A complement. So what this will be, these two are commutative. So how can I write this? A intersection, this one. So how can I write this as, I can interchange. So this
A
will be
union B intersection C complement.
and B complement. This will become sigma. This will simply become B complement. Yes, tell me, Manas.
A union B intersection C complement.
A union B
Whole
intersection,
intersection C complement.
whole intersection. This,
Yeah. So C would not be included in the at all.
if you take A union B, it will consist of this
And
complete part will be there.
but then we took the C intersection C complement. So C wouldn't be included at all.
But yeah, intersection C complement is this. Yes, it is correct. Fine. All three events occur.
A union B union C.
A intersection B intersection C.
A
Intersection,
intersection B
sorry.
intersection C is intersection.
कैसे होगा साक्षी?
I was a bit confused.
Okay. E. None of ABC occurs. F. Exactly one occurs. So none of ABC occurs, it means that A union B union C complement, right? Which can also be written as A complement intersection B complement intersection C complement. So none of the event will occur. Exactly one occurs. So I need the elements from this part, this one,
Sir,
or it can be in this part, or it can be in this part. How can we define this set? Just tell me, Saurabh.
sir, I feel that A intersection B complement intersection C complement.
Yeah, that's it.
No.
Anyone else? 9:30. Amol sir will be waiting. So one is correct. A intersection B complement intersection C complement. So this won't have any element from B and C. Only one event will occur, that is A.
But then union and same for
Hmm.
the other two.
Yeah,
B intersection A
exactly.
complement.
Exactly. A complement intersection B intersection C complement. Again union, A complement intersection B complement intersection C. What about the third one? Exactly, 2 occurs. So
A
I'll just
intersection B in okay.
intersection B intersection C complement
C
Okay.
complement union
intersection B complement intersection C union A complement intersection
complement.
B intersection C. So in this event, only exactly 2 will occur. Fine. So that's all for today. I'll solve 1 or 2 more examples covering all the types, and then we'll start with the new topic.